Good evening, folks. The last stand, the final reach is underway. Those looking for dark matter are at the end of the road, a road we said they'd walk now over a decade ago, only to arrive at nothing. Liquid xenon detectors, argon detectors, collider experiments. In 2011, we bet against billions in funding and the world's best scientists and boldly proclaimed they would find nothing. So far, we've been right. Now, the first round of the finale is in the books and nothing has changed. I want to bring folks up to speed on our claims, what has been discovered, and do so with the best clips from our 2019 plasma cosmology movie. We will come back at the end for another bold proclamation, but we're going to start with a dark matter reality check. We have our milk carton here.
It's not there. It's just not. This dark matter model is probably not completely correct. Taking all these together, it poses a real problem for our understanding of cosmology. We have had to sort of invoke some tooth fairies to keep things sensible. One of those is dark matter. Supersymmetry is my favorite example. It was a beautiful idea, very compelling, was basically accepted widely in the 80s. All the predictions that supersymmetry made have failed badly. And the most popular form of dark matter, the WIMP, is a supersymmetric particle. So you only have WIMPs if you have supersymmetry. And so now we've gotten to this weird point where most people seem to have forgotten that you need supersymmetry to even have WIMPs. Now we have WIMPs because we know we need to have this dark matter, but the supersymmetry that is required to make those things exist doesn't work. And it's failed in lots of ways. When things go wrong, you have to bear in mind that maybe we got something wrong along the way or missed something that is important.
Sophia. They did spend a lot of money on Sophia. It was supposed to help solidify this force of gravity model for the formation of stars and star clusters. They found out that not only are magnetic fields and turbulence, and when you see turbulence in this realm, they're talking about plasma turbulence, plasma interacting with itself and interacting with electric and magnetic fields, not what many of you might have experienced on the flight here into the rain and clouds yesterday. But so magnetic fields and plasma turbulence are not only involved, they may dominate the creation process of these stars and star clusters. The missing mass of the universe is tracing the cosmic filaments. Now, this is where mainstream scientists say, okay, but that was just the normal matter we knew was missing. We still have all this other stuff we need to look for. The problem is, finding all of the missing matter scattered about is very different than finding it in a current. And we know that these cosmic filaments feed material down onto galaxies. So when you have all this material and it's not spread out, it's actually in the cosmic filaments. It's traveling the same direction, feeding galaxies. It is a current. There are magnetic fields wrapped around it. They see protons, they see electrons in these things. And so matter is no longer just matter. when it's in a current. Okay, if it's spread out everywhere, it has its gravitational attraction. If it's in a filament, it has its gravitational attraction, but it's got a lot more than that, doesn't it? It's creating magnetic fields. It's creating electric fields. And that way, a baryon, a proton, is no longer just a proton. It's now doing a lot more, and it's affecting a lot more. Okay, well, if this really is a whole magnetic mess, then we should be really seeing these with every little structure. And so what you see here, when you see a blue circle, that means the magnetic fields are wrapping towards you. Red means they are wrapping away from you. And you should see the white filaments in the middle of them. Every single one they've looked at, there must be a current hidden that they cannot see running through the filament because the magnetic fields are uniform and wrapping around it, just like you'd have a magnetic field wrapping around electricity going through a wire. Now, they can't see the electricity going through these filaments, but it must be there. Otherwise, the magnetic fields would not be uniformly wrapping around it like this.
In 2018, a NASA article, basically out of nowhere, mentions our existence in the plasma universe, which was a baffling sight to see for those of us who know how many plasma universe physicists don't think dark matter exists. One of the projects that has received very little attention and which we really don't hear much about is poised to be the next leap forward in our understanding of the real dynamics of cosmological constituents.
I'm Anthony Peratt from Los Alamos National Laboratory, U.S. Department of Energy. I started out in plasma cosmology under the Nobel laureate Hannes Alfvén. Alfvén had written a book in Swedish called Cosmic Plasma. Well, I know something about Swedish and certainly I know something about English. So I wrote the first English edition of Cosmic Plasma under Hannes Alfvén's name. One of my fortes was supercomputer computing of large-scale matter. So for 12 years we did teraflop computing, the full set of Maxwell's equations on matter, electrons, ions, and neutrals, only three-dimensional. In other words, real-world calculations. And from that we were able to, much to our surprise, calculate the full evolution of plasma and neutrals acting under gravitation, plasma acting under electromagnetic forces, and recover the evolution of plasma collected in the universe as it evolved towards a galaxy and eventually a spiral galaxy.
Alfvén, Peratt, Birkeland, the three founding fathers of the plasma universe. If there is an accretion of the intergalactic medium in those regions, meaning outside of the galaxies, then the orbital velocities of neutral hydrogen clouds are determined not only by the gravitation of mass inside their orbits, meaning that if you have a bunch of stuff where we think there's empty space outside of the galaxy, if it's there, I know we can't see it, and most astronomers don't think it's there, but if it just happens to be there and we can't see it, the math says you don't need dark matter anymore. And I'm going to go back up here. This is what Christian Birkeland said. We have assumed that each stellar system in evolutions throws off electric corpuscles into space. It does not seem unreasonable, therefore, to think that the greater part of the material masses in the universe is found not in the solar systems or nebula, but out in the empty space. What we didn't know is that the active plasma nucleus, supermassive black hole, whatever you want to call these things at the centers of galaxies, they are feasting on many more stars than we realized. And in addition to feasting on many more stars than we realized, they are blowing out an enormous fraction of that which they take in, up to 80%. So this whole stuff is getting eaten by the black hole? No. A lot of it's getting shot out the cosmic jets, and a lot of it is getting blasted out. Well, here's the thing. We know for a fact from the observations that the stars are going in. We know for a fact that the material is getting blasted back out. But they look in the inner galaxy and that plasma's not there. They look in the spiral arms and that plasma's not there. It's been blasting out from the center of the galaxy for billions of years, but they don't see it in the middle. Where must it be? It must be around the galaxy. There's nowhere else it could be. Now, that's some pretty impressive circumstantial evidence, but it's still just circumstantial at this point. So let's see if we can gather up some more real evidence for that material being out there. Well, you remember this? The most well-studied dust ring around a star ever. And then somebody widened the field of view and realized there was 1,000 AU dust belt around it. There is a widespread presence of nanometer-sized dust grains in the interstellar medium of galaxies. We're going to come back to that in just a minute. Because this is when the whole thing should have fallen apart. Does anybody know what you're looking at here? Do you remember this is just a couple of weeks ago, the lost light of Hubble? The white areas on here, that's areas where they still have no return. Just looks like black empty space as far as you can see. The colored areas are the galaxies that they know. The black areas around them are the dust and gases and other things that they knew of. The gray stuff around those is the lost light of Hubble. So around all of these galaxies, where they could not see before, is a whole bunch of dusty plasma, a whole bunch of emitting sources exactly where they were predicted to be by the plasma universe, and in the place where, mathematically, dark matter dies. But getting into this dusty plasma and why this is so problematic for cosmology, because it is a trickster. It really is. And so I'm just going to read some of the stuff up here. When they were doing these experiments with dust on the International Space Station, there was not chaos, but they noticed order imparted on the dust. It lined up. It formed waves. It formed crystalline structures. Now, they determined that these crystalline structures and the lines and the waves were based on electric fields. That's how they were lining up. It wasn't based on gravity. And so when you have these regions around the Earth, around the solar system, around the galaxy, interacting with electric fields, forming these crystal patterns of dusty plasma, it basically means we are looking at the cosmos through a kaleidoscope.
They can't seem to get the correct results, and they seem to think it's due to some magic essence that they have left out, and they call it dark matter. So as a result, you have several hundred professors, graduate students that are working towards their PhDs somewhat, that are pursuing dark matter without any knowledge of what it is. There's no missing matter at all. We just had a lot of experimental data that we could compare the simulations to at energy densities that universities, graduate students, professors, associate professors, full professors, professors emeritus simply did not have access to. We did. Now the universities really, and I had a choice once I had a PhD. I could go into a university and get tenure eventually, or I could go into a national laboratory and work with real data, real equipment. My gosh, the equipment that we burned up in the first millisecond of a nuclear explosion underground was just more than all of the universities in the world could afford. They simply can't afford that, to lose that kind of that investment in high power, sophisticated measuring equipment so quickly. And plus you're working in an environment where you're working with real world physics, not the physics that you learn in textbooks, that maybe 5 years old, 10 years old, 200 years old. This is real world stuff.
Next, we wonder about the 3D simulations that they do have now, and one of the most renowned is Illustris. The problem is that the mistakes that drove matter physics into darkness have progressed far more quickly than the reduction in price of supercomputing. And what this means, practically, is that since the universities attained the ability to work with this level of computing, they have included dark matter and dark energy to a degree dwarfing the luminous matter, and have lacked the luminous matter being discovered by the weak, the dust, the plasma, connecting galaxy clusters and clusters to the cosmic web, surrounding the galaxies and controlling star-forming regions. The natural extension of these discoveries is the electrical action at various scales throughout the universe.
Let's say I burn toast in my house, and I mean really burn it. I put it all the way up, I smell it burning, I see the smoke, and then I just kind of like turn my back and I let it go for a few more minutes. Then let's say I eat the piece of toast anyway, because that's how I like toast, and then I take the toaster and I throw it out the window. Then I bring you into the room and I say, find the source of that smell. You have no chance, because I've eaten the toast, I've thrown the toaster out the window, all the evidence is pretty much gone. All the evidence you'd want to really understand it. And that's what we're talking about with a potentially extinct current here. Something caused these and it wasn't gravity, to form like this, like lightning throughout space. And that thing really might not be there anymore. We might just be seeing the aftermath. The smoke trail from the meteorite that blew up 4 or 5 seconds earlier, and there's no more light from it. It's just the essence of it. It's the smell of the burnt toast that's left over. And so now we come back to a story that I think most of you probably know about. They flew Cassini through the water jets, the South Pole of Enceladus. Magnetometer, hot and running. Langmuir probe, hot and running. They detected phenomenal magnetic fields and only 5% of the requisite electric current. So that is a satellite flying through the electric current. We call that in situ measurement. And it detected 5% of the electric current. This is important for 2 reasons. One, if we can fly right through it and only detect 5% of the current, we see nothing from Earth. Looking out into the cosmos thinking, oh, well, we don't see these electric currents in the cosmos. No kidding. Good luck seeing them if you spotted 5% in situ. But the explanation for why it was hidden, the charged particles of the current were actually being attracted to and hidden by dusty plasma. The dust was actually hiding the ions. The reason they were not able to see the current of charged material in the cosmic web was because of the dust. The exact same thing they ran into in Enceladus. And not a single astrophysicist or cosmologist has put these two together. The same problem that they ran into at Enceladus, which should have given them a clue about how pitifully they see electric currents in deep space, they have already run into with the cosmic web. Oh, well, that's where the normal matter is flowing in that current. We just didn't see it because of the dust that was surrounding it. It's right there. The number one model that's coming out is this torus jet model. Regardless of whether or not it's a black hole, a plasma nucleus, what's around it is a torus and a jet. We don't know what's down there at the exact center. People have a lot of good guesses. But what's just outside of it is observationally undeniable. It's a torus and a jet. And this is what you get when you have that energetic point. And so in the image on the far left where you can really see the jet going up and down and the torus around it, you can't see the full Z-pinch there of everything coming into the middle with the torus wrapped around the waist of the Z-pinch, so to speak. But that's what we've got there. And they fade as they go up because they're losing energy. It's more dark mode rather than glow mode plasma as you get way, way out there, and specifically as it starts to arch back around and make the larger torus. But you can see the interior of the torus here, and this is Billy's first try over there on the right, just doing the fundamentals and turning on the power. He created the jet torus model right there before our eyes.
You know, Dr. Peratt's open letter to the scientific community now has dozens of signatories from the field, dozens more in related science and research fields,
It's not shocking that the national labs do seem to be nailing it. There are a number of people on that signatories list that are from the national labs. It's not shocking that Peratt did it in Los Alamos. It is, as you said earlier, it is just a shame that his work had to be classified due to the nuclear connections.
I might add that this is a very exciting time to be in physics and to be in the field of astronomy, and by astronomy I mean astrophysical plasmas, because so much data is pouring in now that is providing justification, which we already knew because we'd done the large-scale experiments. It's the physics, the high-energy density physics that you're allowed to get into going into the national laboratories. And this is void in the universities. Name a university and they simply do not have the funds, they do not have the equipment, they can't do high-energy density work as is required when you're looking at the universe. The universe is the biggest pulse-power generator we have and the largest high-energy density media that we can experiment with. So all they're left with is ignorance. And for that reason, a large majority have gone to dark matter, invisible matter, missing matter, ghost matter, so on, to explain the failures of their codes. They publish a good many papers, and really, university physics is about publishing papers, be it right or be it wrong. And in most cases, especially with missing matter, it's wrong.
Unfortunately, the situation is even less rosy than the picture painted by Dr. Peratt. I conducted the interviews for this infomentary, a dozen others that didn't make this infomentary, and there were numerous other interactions via phone, Skype, email, even in person, with no less than 95 of the professors currently teaching these topics to today's youth in the United States, Canada, Australia, and Europe. There was a disturbing trend that I seemed to notice as I was talking to professor after professor, and many of them were not shy at all about admitting this. They are grossly incapable of keeping up with all of the science that is coming out that might potentially affect their field, might potentially affect their work. Now, there are 3 reasons why this is the case. First, professors are busy. In addition to any research or paper publishing or experiments they might be doing, they probably have to teach classes. They have to grade papers, they have to grade tests, and there's also an enormous amount of administrative work that goes into the individual students, the department, and the university as a whole. Second, this is actually not one field, but many fields rolled into one. Astronomy, astrophysics, astrophysics of galaxies and galactic dynamics, magnetic fields, plasma turbulence, large-scale cosmology, dark matter, black holes, nebula, gaseous and dusty star-forming regions and their interplay altogether, each one a very specific and highly specialized field of science. What it takes to be a player, publishing in just one of them, pretty much boggles the mind. It's very difficult to keep up with many high-level fields of science. And that brings us to number 3, which is the one that most of them identified themselves as being the major problem. There are so many places where this information is coming out, and there are just only so many hours in the day. The Astronomical Journal, the Astrophysical Journal, Astronomy and Astrophysics, the Astrophysical Journal Letters, monthly notices of the Royal Astronomical Society, Nature, Nature Astronomy, Physics of the Dark Universe, Physical Review D, and Cornell's preprint archive, 5 days a week. We're talking about 50, 100, sometimes 200 new papers a day. And they're not all going to be relevant, but you have to scan through all of them. And a good dozen to 3 dozen probably are relevant. It's just not possible to keep up with all of those other things when you have a professorship, when you're doing your own research, leading your own research, when you have all those other responsibilities. It really does require a full-time, dedicated passion for keeping up with all of these material. And the interesting thing is most of them have the passion, they just don't have the time. And we're back to today. After reporting this last week, one of the last WIMP dark matter search failures, with a bit of an attitude, I got an email from one of the professors on the project who has long been familiar with my disdain for dark matter and Big Bang science, and who knows I said in 2011 they would never find anything. And they asked a question I have answered before. Why do I beat a dead horse? Why have I taken that same attitude for all 161 times I've reported their failures to find what they're looking for? Why can't I just let it die in peace? She must not have heard my answer to that question back in 2019, so I'll repeat myself. The answer is you don't fear that death. You'll just jump to the next candidate, like Axions, and get more of our tax money and grants. Your punishment must be more severe. So when these final studies come back again with nothing, when the world truly understands the depth of your failure, and when WIMP cold dark matter models are ashes, then dark matter has my permission to die. Oh, you thought darkness was your ally, but you merely adopted the dark. Light was born in it, molded by it. The heavens saw nary the light until on its own it could stand, and I see now it's nothing to you but blinding. The shadows betrayed you, because they belong to the light. I'll see you in the morning for the daily show. Be safe, everyone.